Welcome to this program, and this lean training program is designed targeting a wide range of employees working in factories. The content of this program is designed to be inclined with ASQ, BQF and other leading quality bodies. This program is designed to be highly effective with all manufacturing sectors. After you complete this program, we have provided you the option to obtain your official yellow belt certificate. This is how your official certificate offered by us will look like. This is what you will learn in this program. In section 1, we will discuss about the fundamentals of lean manufacturing. Then we will discuss about eliminating the 8 forms of Muda. Then we will discuss about push versus pull production, then about JIT and about single piece workflow. Then you will learn about the throughput time and the lead time. Then about employee engagement and quality circles. Then you will learn about problem solving and analysis tools like different types of graphs, then Ishikawa diagrams, and about the YY analysis. Then you will learn about Kaizen and Six Sigma. And then we will discuss about the 5S or the 6S system and about Gemba walk. And finally, we will show you how to take the yellow belt exam and obtain your certification. We hope you will enjoy this program. Now we will learn about what is lean manufacturing. The idea of lean manufacturing was developed in Japan for doing things better by eliminating waste. Now this means we are trying to operate our factory by doing things better. And these lean concepts goes back to the 1950s. Now this lean philosophy in manufacturing stands on 3 principles. The first one is elimination of losses leading to poor performance levels. Now this means reducing the losses which are associated with Muda, Mura and Muri. Then the second one is involving all the employees with the production operations. Then the third one is continuous improvement. Now this means continuous problem solving involving the Kaizen and Six Sigma DMake approach. Then working on change projects, maybe involving change management models. Then involving the PDCA, SDCA approach. And then working on various continuous improvement activities like 5S implementation, then TPM implementation, then maybe implementing Jidoka projects, then integrating Pokayoke, then work study approaches, and likewise. Now, if we know the steps or the procedures, we can simply implement these projects. Now, the main outcome of lean manufacturing is to achieve a high performance production setup. Now, this means a production setup with reduced process waste, then less or no waiting, then highly engaged workforce, then involving improved production techniques, then improved speed and volume, then a culture with continuous problem solving, then achieving reduced operating costs and a safe workplace, and likewise. Now, generally, to evaluate the production performance, we will use measures like productivity, then utilization, then efficiency, and we may use the OEE. Now, you will learn about all of these things very deeply if you will follow our Lean Black Belt program. Thank you very much for staying with us, and we welcome you to stay with us until the end of this program. In this lesson, we will learn about the 8 forms of lean waste. Lean waste, in otherwise Muda, is defined as activities does not add value to the process or to the end product. When we are transforming the raw materials to the finished products, there are many activities we should perform. The raw materials and the finished products. There are many activities we need to perform in this transformation process. But if there are activities that does not add value to the process, then it is considered to be a waste. These non-value added activities are a cost to the organizations. No one wants to pay for these. And there are 8 forms of lean waste or Muda. These are the 8 forms of lean waste. And we will learn about all of these in our coming slides. Now, we should know that still there are activities such as quality inspection which add no value to the end product, but it is really needed in manufacturing. Therefore, this won't become a Muda. Now, the first form of Muda is Muda of transportation. Transportation involves the movement of finished products, then inventory or work in progress. So simply the movement of the physical goods. Now, this movement could occur within the plant or within plants. Therefore, Muda of transportation is simply the excess movement. Now, with this example, we will try to understand this. The production illustration of IRK aviation is shown below. Components made from plant 1, plant 2 and plant 3 needs to be transported to the assembly plant. It is assumed that it requires $2 per kilometer. Calculate the total cost associated with transportation. So now we have plant 1, plant 2 and plant 3. Components made from these plants needs to be brought here. If we calculate the total transportation requirement 100, 200 and 50, the total becomes the sum of all of these three values. So it is 350 kilometers. Now the cost associated this 350 should be multiplied by $2. Then we will get $700. This is the cost associated with transportation. End of the day, we need to add this to the end product, and we need to always try to bring down this. Value stream maps are used to identify Muda of transportation, and we will learn more about this in one of our coming lessons. Transportation waste or Muda of transportation can be reduced by relocating plants, so bringing the factories closer. That's where you find manufacturing cities or industrial zones. Then changing the plant layout. We will learn about this also later. Then making a process change, so changing the manufacturing setup. About that also we will learn later. Then changing the inventory setup. We can maintain a small storage facility near the production area. Likewise, there can be many ways to reduce the Muda of transportation. In many situations, we cannot make Muda of transportation zero, but we can try to reduce it. The second form of Muda is Muda of inventory. Muda of inventory occurs when materials or inputs stack up before any process or operation. So simply we call this as the stockpiles. Now when we take a production process, we have inventories of raw materials and the inventories of finished goods. About this part we will talk under another topic. So, Muda of inventory mainly refers to the raw materials or the stockpiles of work in progress. Inventory mainly generates when the production plant adopts batch production. Batch production means we produce a defined quantity of products. For that, we need to have high amount of inventories of raw materials. And another reason for this is have unbalanced or poor production planning, so poor forecasting. This is associated with Mura and Muri, which you will learn later. Then it is always recommended not to practice batch production. Instead, move to JIT production. But sometimes we have no option unless adopting batch production. Then comes Muda of motion. This form of Muda refers to how employees themselves move during a process. Let's say this is the plant layout and the movement of the employees. To study the movement of employees within the plant, we will use spaghetti diagrams, and you will learn more about this in one of our coming lessons. Simply, this is the excess motion or the movement of mainly the employees in the factories. Motion is often relevant to people-powered processes seen in the production flow, then in the warehouses and with material handling. Factors that could multiply Muda of motion and how to overcome such. The first one is poor plant arrangement. So let's say if the employee needs to move within machine 1 to 4 frequently, this is sometimes called as vibrant motion, will lead to high amount of Muda of motion. Therefore, we could reduce this with the U-type arrangement. So, he or she can easily access any machines. Then, the second one is inconsistent work methods or no SMPs or standard manufacturing procedures. Then, to overcome this, we need to design the SMPs. Then, poor workplace organizing or poor housekeeping is a main identified cause for Muda of motion. Poor housekeeping will lead the employees to always keep searching for tools, then keep searching for raw materials, then documents and other things. And employees will need to put more effort on cleaning, and there could be many things like this. Therefore, the 5S method is a proven method that helps improve workplace organizing, and this will result in reducing Muda of motion. We will learn more about 5S and how this could be done under the 5S section. That's all for this lesson. Now let's move to the next part. This is the second part of the previous lesson. Then comes Muda of waiting. Muda of waiting refers to any idling time or idling process either for machinery, people or the work in progress. So let's say process 2 and process 3 are ready, but process 1 is not ready. Maybe some technical issues, and the technical department is not properly informed. So because of this, the employees and the machines in process 2 and process 3 will need to wait. Machine or people working below capacity will lead to high amount of waiting. Let's say process 1 and process 3 are working normally or operating normally. Then the process 2 operator is working very slow. Then we will see small amount of inventories piling up here. The process 3 will not have work to do, and the speed of process 1 will need to be reduced. Generally, waiting occurs when intercoordination fails. The coordination within departments or the suppliers. And then if the processes are unreliable. The fifth one is overproduction or Muda of overproduction. Overproduction means a product or service that had been produced either at a wrong time, so when there is no demand, or produced in too much, so producing very high volumes. Let's say the demand is only 10,000 units per week, but we are producing 20,000 units per week. Every week we will have 10,000 units adding to our inventories of finished goods. This is clearly overproduction. Then replacing the production system with JIT production or just-in-time production, or sometimes with smart JIT. This means it is a mix of the push and pull production systems. We will learn about it later. Is the ideal solution to overcome overproduction. Then comes overprocessing. Muda of overprocessing occurs when over inputs or more resources are added into a product or service. So let's say this is the finished product and we can produce it with only processing 1 and processing 2. But we are adding 2 more extra processors. Then these 2 becomes a waste. As for an example, if we need to apply only 2 coats of paint but we are applying 4 coats of paint. Clearly, we have overpainted or overprocessed the product. Overprocessing occurs due to various reasons such as overexcitement, So let's say this happens mainly with the new product release or with any worker who is new to the job. You have the fear that this is not enough. Then comes poor training provided to the employees. Then the process is overdefined. So there are excess processings like this. And the customer requirements are not properly understood. That's all for this lesson. Now let's move to the next part. This is the third part of the previous lesson. Then comes Muda of defects. This type of Muda refers to products which require reworking. So the defects or the mistaken products. Manufacturing defects could occur either at the beginning or during the production process. Defects occurred in the beginning are called as startup defects, and defects occurred during the process are called as process defects. You will learn more about this later. Then reworking will require additional time, additional material and additional labor. It is a cost to the organization. Then one of the main objective of Lean Six Sigma or manufacturing excellence is to minimize defects occurring. Then comes non-utilized skills. Skills or talent is wasted if employees are not used for tasks and activities where the talent is based on. Now this is called as underemployment. So let's say from the skills available in an employee, if we are utilizing only 30%, then 70% of it becomes waste. We are taking very little work from the employee or from his capabilities. Waste in talent is more a concern of HR related, and the main causes for poor talent utilization are hiring the wrong person or putting staff in the wrong position. Now let's try to understand more about Muda with this example. Following is the bread making process in a bread making factory, and let's try to understand how Muda could develop here. Now this is the bread making process. So the mixing, then the kneading process. So by this we try to make the mixture soft, and then comes the shaping process. So we put the mixed flour into the molds, and then comes baking, and finally packing and distributing. If we need to bring the raw materials from a long distance, then this means more transportation, so more cost associated. This means Muda of transportation. Then if we need to maintain high amount of raw materials, it is again a cost, so Muda of inventories. Then if the plant is not properly optimized, then we will see Muda of motion. Then if the production cycles are not properly balanced, or if the production is poorly planned, then we will see Muda of waiting. Then producing above the daily requirement will result in Muda of overproduction. Then over-processing, this means over-baking or maybe over-mixing, will lead to a defective product. Defects could form in different stages of the process, and we need to identify it. Quality control plays a vital role here. And if we did not use the right employees, it will result in non-utilized skills. That's all for this lesson. Thank you very much for being with us. In this lesson, we will learn about push versus pull production systems. The push production system. Push production means producing goods which is not based on the actual demand. This means we are producing to stocks. If you look at this illustration, we see that the market demand is only 10,000 units per week. But we see that we have a continuous production, producing 20,000 units per week. So we see that we have overproduction, and all the finished goods will be stored in the stores or in the warehouse. To maintain this sequence, the organization needs to maintain high amount of inventory of raw materials. The push system is a method which will lead the organization for generating Muda of overproduction. Then push production will always lead to high operating cost because it is needed to maintain high amount of inventory. It becomes the both ways: inventory of raw material and inventory of finished goods. The pull production or the JIT system. The pull system is only named as just-in-time production. Pull production means an organization manufactures goods based on the actual demand. The process begins only when an order is made. Unlike the previous one or the push method, this process begins with the consumer order. The order management department will inform the production department. Then the process begins. They request for raw materials from the stores department, and then the production begins. Here the products are produced based on the demand, so sometimes extra buffer is added, so they might produce 20% more than the requirement. This is done for safety reasons. Based on the demand or the production pattern, a decent amount of inventory is maintained. This is always done to prevent any kind of JIT failures. Then JIT will result in reducing the operating cost due to the optimized inventory management. Then this is the concept where producing the exact quantity of the right part at the right time. Now we have come to the end of this session. Thank you very much for staying with us. Now we will learn about single piece workflow. Now, in this method, a product is processed in one stage and then moved to another stage, which is again followed by the other products. Now let's say this is our first processing stage and this is the second one. And let's say if this is the starting point, initially we need to take the raw materials or the work in progress and process it under processing stage 1, and then this work in progress will be moved to the processing stage 2, and then after the value is added, it will be moved to the next processing stage. Now this is how this method works. It is a continuous flow. In every processing stage, some value is added to the work in progress. Now this is how it works with the garment industry and in vehicle production lines. Now let's say in the body production line, in every workstation, some value will be added to the product. Maybe some parts are welded, then maybe some parts are fixed, then maybe the doors will be fixed, then maybe the windshields will be fixed, and likewise. Step by step, value is added to the end product. Now this is how it works with the chassis assembly line. Initially maybe the suspension systems are fixed, then it is moved to the next workstation. Then there maybe the engine and the gearbox will be mounted, and then it will be moved to the next station, and likewise. Now this is how it works with the garment industry also. Let's say a t-shirt like this is produced part by part. Initially it will be the cutting stage, and then it is moved to the sewing stage. In the sewing stage, there will be multiple sewing operations adding value to this t-shirt, and it will need to move forward stage by stage. And about this example, you will learn very deeply under our work study sections. Now, with this method, it is easy to identify defectives. Now let's say in this process number 2, something went wrong and we noticed a defect in this product. Now what happens is, we can stop the process immediately and fix the issue. In this case, maybe we will need to rework only one product. Then the third one is parts are moved through the process with little or no waiting time at an optimal rate. We will learn more about this under the cycle time section, which you will learn later. Now, with this method, we will not see additional inventories piling up, or we will not need to maintain a high amount of inventories of raw materials, as it is not adopting the batch approach, where you will be producing plenty of goods at a time. Now this is simply the approach of continuous manufacturing. The benefits of single piece workflow. The first one is easy to identify defects and less cost of reworking. Now, as we saw previously, only the first product undergoing some processing or some defective processing will need to be reworked. Then it reduces the inventory levels. Then less space is required. Now, mainly due to less inventories and less work in progress, and due to the optimized flow, we will require less space to work. And it reduces the complexity of the job. Now in this method, the work will be divided to many sub-processes or to operations. Therefore, the employees will not be stressful, and because of this, we can reduce the cycle time, which you will learn later, and enhance the manufacturing flexibility. Now in this method, usually we can customize every sub-process. Now let's say a customer wants to manufacture 1000 shirts, and all of them should be white color. And from this order, if they want only few shirts to have red color pockets, maybe 10 shirts, this can be easily done. That's all for this lesson. Thank you very much for being with us. Now we will learn about the throughput time and the lead time. The throughput time. Throughput time is the amount of time it takes for a manufacturer to make a product. Simply, it is the time taken to produce a product. Now, this time will include the cycle time, then the process time or the processing time, then the inspection time, then the transportation time, waiting time, and it could be other time values associated in manufacturing the product. It is simply the time required for a product or a work in progress to move from the beginning to the end of any sequential process. Now this means the time required to produce any product in any sequential or any operations which is mainly in series. Now, the equation to calculate the throughput time is, it is the total of the cycle time, the process time, then maybe the loading time, then maybe the waiting time, inspection time, transportation, and likewise. Now, with this example, we will learn more about this. A factory is in need of calculating its total throughput time. Therefore, they have computed the following values. Calculate the total throughput time. Now, they have given us some time values. The transportation time, then the waiting time, then the inspection time, and likewise. So, how to calculate the total throughput time? Now, we need to assume that these are the total time values required for this process from time 0 to the end. The total throughput time is, it is the total of all these values. If we add all these, we will get 30 hours. Now comes lead time. Lead time is known as the amount of time taken from the moment a consumer places an order to the moment the product is delivered or received by the consumer. Now let's say there is a series of processes in producing the product. And let's say we have finished the product to a certain amount and we maintain a small inventory here. Now let's say when a consumer places an order, if we will need to just pick the semi-finished product from here and do some processing and then deliver it to the consumer, then the lead time is only the time taken for this process. Always we need to stick with this definition. The amount of time taken from the moment a consumer places an order to the moment the product is delivered. And we will be needing this definition to maybe solve different examples in our coming lessons. Now, this includes the relevant time taken to produce a finished product. If this is the finished product, the time taken is T1. Lead time may include all the activities, whether it is wasteful or not. In many occasions, the lead time is interchanged with the term throughput time and sometimes as the cycle time. Now you will understand more about this in our coming lessons. Now, with this example, we will try to understand more about this. A customized aluminium sunglass factory produces eyewear only based on consumer orders. So, it is operating on JIT principles. Following is the operational procedure. Based on the illustration, calculate the throughput time and calculate the lead time. So, it is a process of producing aluminium sunglass. Initially, the frame is machined or cut from the aluminium block. This requires 60 minutes, and then the cut frames are safely stored. We will always have a small inventory of cut frames. Then comes the painting process. This requires only 15 minutes, and then the painted frames are also stored separately. And the final stage is inserting the lens. If the consumer makes the order, then what happens is the person working in the factory will take a frame from here and then insert the required lens and deliver it to the consumer. The lead time is going to be only 5 minutes, and the throughput time will be the time taken for the machining, then the time taken for the painting, and the time taken for the lens inserting. The throughput time is 80 minutes. And as I said, the lead time is only 5 minutes. That's all for this lesson. Thank you very much for being with us. In this lesson, we will learn about total employee involvement and the concept of quality circles. Total employee involvement or employee engagement is the extent to which organizations need to work in making employees from all levels involved in their continuous improvement or lean implementation program. This means involving all levels of employees for the improvement of the organization. Employee involvement strategies. Now, how are we going to involve or engage the employees? The first one is need to reward and provide recognition to the employees. Then need to involve the employees in decision making. Then need to provide continuous training to the employees. Then need to provide various welfare benefits. Then the CEO should frequently meet the employees and communicate with them. This concept is meant by Gemba walk. Then need to provide a safe environment to work for the employees. Then need to authorize employees to form groups among similar categories and solve their own problems. This is the concept of quality circles, which you will learn in the next slide. The concept of quality circles. Quality circles means a formed group of employees of similar categories for the purpose to identify and solve their regular problems. How do we understand this? So let's say we have a plant and we have 3 different sections. Production Section 1, where there are 100 employees. Then Production Section 2, where there are 120 employees. Then the Maintenance Section, where there are 50 employees. Now, a quality circle can be formed for Production Section 1, maybe involving like 10 employees. Likewise, in all sections, quality circles could be formed. Then these employees could get together and solve their regular problems. We have come to the end of this session. Thank you very much for staying with us. Now we will learn about data representation with bar charts and pie charts. Data representation mainly refers to how data could be displayed in any simple form. Now, that is the idea of this. And there are many methods that can be used for this purpose. And in this lesson, we will be talking about bar charts and pie charts. Bar charts are used to plot numerical data values either in horizontal or vertical bars. Now here we have used vertical bars, and this represents the count of something, maybe the number of products produced in a week. When it comes to pie charts, we use this to illustrate data in a circular form, mainly to illustrate the portions of the total or the percentage values. With this example, we will learn how to plot these charts. A wooden sunglass manufacturing company produces 4,000 sunglasses for a week, so Monday to Friday. Usually they find high amount of quality rejects, which is around 8 to 10% of total production. End of an average week, the QC team have classified the defectives as follows. Now plot a bar chart and a pie chart using Excel. Now it is a company that manufactures wooden sunglasses like this. And here we have the defect classification, and there are 6 types of defects or errors. Now this is for an randomly selected average week. Now we have created this table in Excel, and there are 6 identified errors or defect types. Normally, these frames are made involving CNC machining. The wood is cut to the shape, and then comes the finishing process. Mostly it is done manually, and then the frame is assembled, and then it will be packed. Now in here, we will see the highest number of errors are due to material errors. Now we know this is wood, and wood will crack or it will deform, and plenty of issues can happen due to the using of wood. Now we will see how we can plot the bar chart. Initially, we need to select this area. Then go to Insert and then click the Insert Bar Chart column. Now in this case, we will select this type. So a clustered 2D column type of chart. Now we have everything what we need here. And soon as we look at this, we know material errors are giving the highest number. Now, if we want to plot the pie chart, again need to select the data, then go to Insert, then click this Insert Pie Chart icon, and we will select this type. Now we can change the format of this. We can easily find out up to 39% of the defectives are due to material errors. That's all for this lesson. Thank you very much for being with us. Now we will learn about the Ishikawa diagram. The Ishikawa diagram, or we call this as the fishbone diagram or the cause-effect diagram, was originally founded in Japan by Professor Kaoru Ishikawa in the 1960s. This tool is used to find the causes for any problem or effect related to production or design issues. Now simply we use this tool to find the causes for any problem or effect, and we will be getting many causes for the problem. Now the structure of the Ishikawa diagram involves identifying causes under different headings. Now here comes the problem or the effect. And we can identify causes under different headings like man, then method, then material, then machine, and likewise. Now these headings are called the M's, and under each M or heading we can find the causes. In the coming slides you will learn more about this. Now, depending on the scenario, we can use maybe 4 M's, then 5 M's, then 6 M's, or maybe even more. This means the headings. If we have more headings, the depth of the analysis will increase. With this example, we will learn more about Ishikawa diagrams. ABC Plastics is a company producing PET bottles. It is identified that the productivity is always slow and the plant operates slow, far below the design speed. This has led the company for higher operating cost, then high defect rate, then poor product output rate, and poor profit margins. Hence, the management hired a lean consultant to identify the causes and address such issues. If it was you, prepare a cause-effect diagram identifying possible causes. Now if we look into the answer, here we have our problem. This means poor productivity. And we are involving 5 headings here. Under each of these headings, we can list down the causes. Now let's say under man, this means the employee factor. So under this, we can find poorly trained employees, then lack of skills and knowledge, then poorly motivated employees and high employee turnover rate. Now, all these 4 causes will lead to poor productivity. Now, under method, this means related to the manufacturing process. So, the first one becomes poorly planned production sequence. This means no heijunka, then plenty of muda of overproduction, then no SOPs. This means no standard operating procedures, then no 5S, and likewise. Now again, these causes are identified under method for poor productivity. Then if we consider material, so using low quality or cheap raw materials, then poor material storage conditions, then improper inventory management system, and likewise. Then under machine, poor machine reliability, then low quality spare parts used, then machines are too old and not refurbished, then no TPM or SMED, and likewise. Then under Mother Nature, this means the operating environment. So causes like very poor factory conditions, then working environment not safe for employees, and likewise you will see all these are identified causes which will lead to poor productivity. Now this is how we will do a cause-effect analysis. That's all for this lesson. Thank you very much for being with us. Now we will learn about the YY analysis. This YY analysis tool was originally developed in Japan, and it is a powerful tool used in problem solving, and we will see how to do it in the coming slides. Now, if a problem is encountered, we need to ask why over and over until the root cause is found. Using 5 whys for this is the most common way, and that's why sometimes we call this as the 5 why analysis. But still, the number of whys depends on the situation. Sometimes we will find our root cause in maybe like 3 whys. Sometimes we will maybe need to go until 6 or 7 whys. With this example, we will see how to use the YY analysis. ABC Plastics is a company producing PET bottles. It is identified that the productivity is always low and the plant operates slow, far below the design speed. Now let's see how to find out the root cause using the YY analysis. Now when we come to the answer, the first question that needs to be asked is why the productivity is low in the production line. Now the answer for this question is due to frequent equipment breakdowns. Now the first question should be based on the problem, and the second question should be based on the answer of the first question. Now it becomes, why do equipment frequently breaks? And the answer for this question is due to failure or failures in the hydraulic systems. Now the third question is, why do hydraulic systems fail? Now the answer for this question that is seen in the factory is due to failure in the control valves. So failure in the inner valve parts. Now a hydraulic system will use plenty of control valves. So valves like this. Now inside these valves there is a shaft balanced with 2 springs or supported with 2 springs. And when electricity is provided to this solenoid assembly, a magnetic force is generated and it will pull or push the shaft, and that's how the valve will function. Now when we take this shaft, there are many oil seals and there are many washers, and that's how we will prevent the oil leakage. Therefore, sometimes the shaft might get stuck, there may be oil leakages, there may be pressure drops, the clearance between the shaft and the bow may be high. Therefore, these are some of the problems you will find in a control valve like this. And here it is simply referred as the inner valve parts. Then the fourth question is, why do control valves fails often? Then the answer is, as they were not OEM recommended, and those are low quality spare parts. The fifth question is, why low quality spares were purchased? The answer for this question is due to less funds allocated for spare parts. Now this is the main problem here. There is less funds for maintenance, or maybe the funds allocated is not sufficient. Therefore, we need to allocate more funds to purchase high quality or OEM recommended spare parts. That's all for this lesson. Thank you very much for being with us. Now we will learn about the concept of continuous improvement with Kaizen and Six Sigma in manufacturing. Now we will learn about Kaizen in manufacturing. Kaizen is a concept involving all employees at different levels. Now this means involving the factory director to the normal production staff to continuously improve all functions in the factory. Now this means for functions like or problems like poor productivity, then unreliable production operations, then various quality issues, then issues in material handling or storage, then unhappy employees or high employee turnover. Now involving all the employees to solve problems like this is the concept of Kaizen. Kaizen can be used. The first way is as a philosophy. This means integrating a continuous improvement culture to the organization. In other words, continuously solving problems using the Kaizen cycle. Now this Kaizen cycle is a continuous cycle that is used in problem solving, and adopting this continuous approach gives the idea of the Kaizen philosophy. Then the second approach is involving Kaizen as an action plan. This means planning for change or improvements on specially targeted areas, or simply using the same Kaizen cycle for any special improvement projects. This means for any specific project without repeating the process. Now this means using the elements of the Kaizen cycle to solve some specific problems, and we won't get into the repeat cycle element. Now, what is Six Sigma in manufacturing? Six Sigma in manufacturing is a methodology of using qualitative and quantitative tools. Quantitative means we are dealing with numbers or numerical values. Then qualitative means we don't involve numbers here, like involving the Ishikawa diagram, then the YY analysis and tools like that, which don't involve numbers. So, involving these tools in problem solving, in otherwise involving these tools in improving the processes, aiming to reduce the defects, then to increase the process consistency. This means the reliability, or simply to produce the planned outcomes. Now, the main objective here is to bring down the defects to 3.4 dpmo. This means only 3.4 defects per million of products produced, or for million of opportunities. Now, this is the Six Sigma standard. If we produce 1 million of products, our maximum defects should be less than 3.4. So simply to bring down to 0 defects. And this is a holistic approach. We need to increase our machine reliability, then we need to train our employees, then we need to integrate better processes and methods, then we need to integrate standards like GMP, HACCP, then the ISO standards, and likewise. And for this purpose, we will use the demake cycle or the demake process, and you will learn about this later. That's all for this lesson. Thank you very much for being with us. Now we will learn about the 5S system or the 6S system. The 5S system is an approach to lean manufacturing that helps to optimize workplace. Now we will use the 5S system to optimize the working conditions. This was initially implemented in Japan along with the Toyota production system in the 1960s. Now this 5S system goes back to the 1960s. Now the 5S system includes 5 elements. So starting with sort or seiri, then set in order or seitan, then shine, then standardize, then comes sustain. Now these are the 5S elements, and we will need to implement these to a production environment if we need to optimize our working conditions. Then later, with time, safety also was added to the 5S system, and then it became the 6S system. Now, what are the outcomes of the 5S or the 6S system? The first thing is we will be getting a highly optimized workplace. Then we can achieve improved productivity, then very high employee satisfaction. Then we can achieve a highly organized working culture, maybe with SOPs, then with standardized information, and likewise. And then we can achieve a safe workplace. That's all for this lesson. Stay with us for the next lesson. In this lesson, we will learn about Gemba and Gemba walk. What is Gemba? Gemba is the Japanese term used to illustrate the actual place. Gemba means it is a place. Then this place is where the work is performed, or it is the area which needs to be visited. As for examples, it could be either a production line or the factory floor, then the packaging area, or maybe a place like this. So it could be any place. Now let's talk about Gemba walk. The Japanese term for Gemba walk is Genchi Genbutsu. Gemba walk means go to the place and see what is going on. Simply this means go to the place. So this means going and visiting the areas. And we will talk more about this in our coming slides. The management or the lean experts should practice Gemba walk. This is where opportunities for continuous improvement is found. The elements of Gemba walk. The main objective of Gemba walk is need to go to the place and see. This should be done by the decision makers, like the managers, then the lean experts, or maybe someone like that. Then, if a problem is noticed, always need to ask why until a solution is found. We need to ask why from the immediate level workers. This is the concept of the why analysis. Then the third one is respect people. Need to identify problems in collaborating with the workers without trying to blame them. There is no blame game here. And Gemba walk is not a boss walk. So if you are a manager, you need to get down to the machine operators level when you want to talk with them. Now let's see how this Gemba walk concept works. So let's say we have a production line like this. And it is seen that this filling machine continuously breaks. Then the technicians will fix it. And again, after 1 to 2 days, this machine again breaks. So let's say this is the plan view of our production line. And this is the filling machine. The maintenance engineer never gives the real reason why this machine fails frequently. Because of that, the lean manager decided to go near that machine and ask the machine operators for the real reason. And then it was found that the problem is with the filling cylinder system. And the maintenance team, they use very cheap parts to repair the machine. But they mention they use the most best ones and claims for more cash. And afterwards, they share that money. The lean manager was able to find the real reason because he went to the production floor and met the machine operators. The benefits of Gemba walk. The first one is ability to gather first-hand information. The managers or the lean experts can talk with the employees directly or see the scenario directly and make their conclusions. They don't need to rely on somebody else's report. The opportunity to get interacted with the employees, then it will lead to increased employee engagement. The employees can directly talk to the management and maybe even discuss their own problems. They don't need to follow the long protocol. And this provides the opportunity to identify areas for continuous improvement. That's all for this lesson. Thank you very much for being with us. Now we have come to the end of this program, and you may follow the procedure as shown in the next slide on how to take the exam and obtain your certificate. And now you are a certified lean yellow belt professional. Now this is how your official certificate offered by us will look like. And to obtain this, you will need to download the exam paper from the below link that is available in the description area. Or you can directly take the exam if we have provided that option. Then you will need to send the filled answer sheet to the provided email address. Or if we have provided the direct link option, then you can just submit it by clicking the submit button or whatever it is available there. Then after you have passed the exam, you will receive your yellow belt certificate, and this entire certification process is completely free of charge. Thank you very much for choosing us, and we wish you all success for your future endeavors.